Hey everyone, this is Daniel for Rock the JVM, and in this video I'm going to show you how you can build a load balancer in Scala with Cat's Effect and Http4s. So this video assumes that you have some basic familiarity with Cat's Effect and Http4s. I have a bunch of videos here on the Rock the JVM channel with both libraries. They should be enough for what you need for this video. I also teach them in depth in my Cats course, my Cat's Effect course, and my absolutely giant type-level rite of passage course. If you want to check them out, I'm going to leave links in the description. So the best way that you can make use of this video is to write code with me. And I also have a written form at the blog with the link in the description as well. The blog version is far more elaborate than I'm going to show you in this video with class hierarchies and domain models and tests and whatnot. That would have made this video very, very long, so I'm going to stick to the essentials. So without further ado, I'm going to switch to my dev environment. Now for this video, I'm going to use metals. For the past couple of weeks, IntelliJ IDEA has been acting up on me, so I'm probably going to upgrade versions or something. So this is the code that you also have access to from the blog post. I'm going to show this code to you very, very briefly after we are done implementing the core load balancer service. So we have a bunch of domain models and error models and tests and everything. There's also a build.sbt, which you can find in the blog version. So click on the blog link in the description, and you will find this build.sbt, which you can import to your own project. Now, here under the load balancer package here, I'm going to create a little folder here. I'm going to call this fast. And under the fast directory, I'm going to create a little Scala file, make an object. I'm going to call this load balancer. And this will be a little object for me where I'm going to store the logic inside. I'm also going to store a bunch of other types here. Now, in general, in company interviews, especially for big companies, we get to a system design question. And in system design, there are a bunch of shapes and sizes for the system design questions. But one popular form of the system design question is implement a lightweight version of one of the popular services like YouTube or Twitter or Instagram or things of that sort. And the candidate starts discussing the components of such an application, how they would talk to each other, and so on and so forth. And very quickly, we get to the issue of scaling. So after the candidate has finished designing or architecting the application with a bunch of components and design patterns and whatever, we get to the issue of how do you make sure that this application can be served very safely to millions or tens of millions or billions of people. So there are a bunch of different questions in that question. And one of the first things that come up in the issue of scaling is that of a load balancer. And the load balancer is a very simple solution to replicating an application that you've already built. And this load balancer would be simply an HTTP server in a very simple implementation that reroutes your HTTP requests to one of the backends that contain the replicas for your application. And those backends would actually do the work, and the load balancer would surface out the responses back to you. So this HTTP server will distribute the load in between multiple replicas. That's why it's called a load balancer. Now, because everything you say in an interview is fair game for the interviewer to follow up, if you say that you're going to use a load balancer, a reasonable follow-up is how do you build a load balancer? So can you sketch a load balancer for me? So let's do that. This is why this video exists, to answer this sort of question or fill in the gap in this conversation. How do you sketch a load balancer? So I'm going to sketch a load balancer. This load balancer, I'm going to design it as an object, and I am going to create a method, let's call this build or apply or things of that sort. And I'm going to pass a bunch of arguments here, so I'm going to mark it to do here. And this load balancer is going to be an HTTP server. So this is going to be an HTTP server. Now, my HTTP server in Http4s, that would be an HTTP routes. And HTTP routes of type IO. I'm going to use Cat's Effect IO. I won't go into too generic a tagless final style in this implementation. Obviously, you can genericize it if you so want. Okay, so these HTTP routes of type IO. Now, I am going to implement that as question marks for now. And I'm going to make sure what kind of arguments I need to pass here. This is the crux of the load balancer. Well, what kind of things do you want to pass to the load balancer? Well, you need to pass a bunch of backends or replicas that you're going to redirect HTTP requests to. I'm going to call this backends, and this is going to be a list. Now, as the candidate says, I'm going to have a list of backends, or maybe a list of URLs. and the URLs would probably be a vector or something like that. So I'm going to use an opaque type. So opaque type URLs as a vector of URI, and URI is going to be a type from org http4s. I'm going to import everything here. So opaque type URLs is a vector of URI, and this is going to be just a URLs type. So this is a plain vector. Now, the question is this URLs thing modifiable? And the answer may depend on the candidate's approach, but I'm going to supply an update function. So I'm going to call this update function as URLs to URLs. So this may be a shuffle function. This may be a round robin logic. This can depend on the load balancer implementation. If the interviewer goes deeper into the load balancer logic, then this update function will store more logic here. Okay. So we have backends and update function. Now, we also need to extract a URI. So I'm going to have an extractor as URLs to option URI. And that is because my URLs vector may be empty. And so I need to be able to extract just an option of a URI. This is the resource identifier of my backend, for which I'm going to reroute my HTTP request. Now, besides these, I would like to also have my logic for sending and expecting a response. So I'm going to call this send and expect response as a function. And this is going to be a request of type IO in Http4s speak and URI. And this is going to be an IO of type, and that type can be a payload depending on the application that you're implementing. I'm just going to return a string. You can genericize it to a particular data type that you want, for example. So I'm just going to return a string, and then you can parse it later, for instance. So this is the send and expect logic. This is the redirecting of HTTP requests. The update function is just to shuffle the list of backends, and this is going to extract the backend for which I will send my new HTTP request. Okay. Now, what else do I need? For example, if somebody tries to hit an HTTP post at my Twitter, mytwitter.com/user/rock the JVM or something like that. This path needs to be rerouted to, I don't know, replica at 8081 / and then I'm going to have to add the same path. So the path parameters and so on and so forth need to stay intact, but the host may change. So I need to also add a bit of logic there to add path to backend or something like that. And this is going to be the URI of the backend, and then request of type IO, which may contain path parameters and payloads and whatever. This is going to return an IO of URI. This is going to be my final replica towards which I'm going to redirect this HTTP request. So this is to massage the HTTP request for the replica. Okay, what else? If we take a look at the argument list, this URLs thing from the backends is actually not thread safe, because as I'm receiving HTTP requests, I'm receiving them concurrently. And as I'm updating the backends, I am probably going to need a reference. So I'm going to use an atomic reference from Cas Effect. So this is going to be a ref of type IO and URLs. So all in all, this is my design for the load balancer. Obviously, if you choose differently, the design may differ, but you'll probably need something along these lines. Now, before we can implement the load balancer, let's set up the necessary infrastructure for the load balancer to work, which is, for example, to build the actual application. And for the actual application, because our focus is the load balancer itself, the actual application is just going to surface out whatever query parameters you've passed or the path that you've accessed. So I'm going to say my object, my app, and this extends IO app. And I'm going to have my override def run, and I'm going to assume that the argument to the command line is going to be my port on which I'm going to start this replica. So let's call this replica. And I'm going to define a val port as args 0 to int, and host is going to be localhost because I'm going to test everything locally, but you can pass these from configuration, for instance. And I'm going to create an HTTP4s server. So I'm going to have a val DSL as HTTP4s DSL. of type IO, and I'm going to import DSL everything. And I'm going to have my routes as HTTP routes of type IO. And my function is going to have my request to an F response. So I'm going to return an OK with, let's say, you've accessed. And I'm going to inject inside this little thing, you've accessed, and I'm going to expand, let's say, request URI path, let's say. So if I hit my Twitter /user/rock the JVM, I will print /user/rock the JVM. So super, super simple. Let me also add the port inside. So I'm going to say reply from replica, or let's say replica colon and port. You've accessed request URI path. So this is my routes. This is my application logic. Let's start the server. So let's call this server, or maybe server. And in order to start a server, you will need a host and port combination. So I am going to create a for comprehension. And the for comprehension will go through two options, because if you create a port option that you can supply to a server, let's call this port option as port.from. Let me import port from the Comcast. So port from int, let's say port. And this little thing actually returns an option port, okay? Because the parsing can fail, the port may already be allocated, and so on and so forth. So I can only work with options here. So I am going to have p as host from, let me import host from the same package, host from string, and I'm going to have my host, and so this is h from host, and p for port, so port from int, and I'm going to have my port inside. I am going to yield, and then I'm going to start my server. So I'm going to say ember server builder. And you know the drill to build an ember server. So I'm going to say default of type IO. And then I'm going to say with host H, with port P, and then with HTTP app. With HTTP app, and I'm going to pass my routes in here. So routes, and I'm going to say routes or not found. And I'm going to have build. So this maybe serve as an option of a resource. So if I want to actually run this application to obtain an IO exit code, I need to say maybe server map, and given the resource inside, I'm going to use it. And with the server inside, I'm going to say IO print line, say replica port, and I'm going to inject port inside. And then I'm going to not stop, so I'm going to say IO never. So for now, this is an option of an IO unit. So I'm going to say get or else. And I'm going to use IO print line, let's say print line. I'm going to say host port combo not okay. And then I'm going to say as exit code dot success, just to make sure that we have a runnable application. Okay, so maybe server map get or else IO print line as exit code success. Let's actually go ahead and start this little application. So after I've saved this, let me actually start an SBT compile. So let me start an SBT console. In the meantime, I'm going to start a bunch of replicas. So replica 1, and I'm going to start another SBT. Inside the compile, I'm going to hit tilde compile to compile in a forever loop. And in replica number 1, I'm going to say run main, rock the JVM, fast replica, and the argument 8081, let's say. All right, so replica port 8081. If I try to hit this endpoint, I'm going to do HTTP get localhost 8081 /user/rock the JVM or something like that. Notice that, say, it says replica 8081, you've accessed /user/rock the JVM. So the app actually works. This is our mini Twitter, which we want to replicate with our load balancer. So let me start a bunch of other terminals here. So I'm going to say, let's call this replica 2, and I'm going to hit another SBT. In the meantime, I'm going to crash this little thing. So replica 1, replica 2, and let me start another one. Let's call this replica 3, and I'm going to start another SBT. And as these things start up, we can go to our load balancer. Okay, now, how does the load balancer going to work? Well, first of all, I need to create an HTTP route. So I'm going to create an Http4s DSL as before. So I'm going to have my Http4s DSL, and I am going to create HTTP routes of IO. And given the request, I need to do a bunch of things. First, I need to extract the first replica, forward the request, shuffle the replicas, and return the response to the user. So these are the operations, not necessarily in this order. For example, forwarding the request and returning the response to the user, this has to be in the same order. But extracting the replica and shuffling the replicas can be done like this. So extracting and shuffling can potentially be done in the same thing. And specifically because we have a ref, we can call get an update on it. So I'm going to say backends, get an update. And I'm going to take the function from URLs to URLs. So I'm going to say update function. So this is going to shuffle my replicas. Now, this expression returns an IO of type URLs. So from the URLs, I need to extract the URI to whom I'm going to send my HTTP request. So I'm going to say map extractor. So at this point, I have an IO option URI. So at this point, I'm going to flat map. So notice that I have an option URI. So flat map. And I'm going to say underscore fold. So I'm going to use fold on options. And if the option is empty, I'm going to surface out an OK to the user saying all backends are inactive or 503 or gateway unavailable or something like that. So I'm just going to surface out an OK. All backends are inactive. And if the option is not empty, then I have a backend URI. Okay, now with this backend URI, I am going to run a for comprehension, and I'm going to forward the request and return the response to the user. So the last two operations. So considering the URI as, and I'm going to use this add path to backend here because I need to massage the HTTP request so that the replica can understand it correctly. So I'm going to say add path to backend, and I'm going to pass my backend URI and the request. And this will give me back a URI, obviously mapped in an IO, but due to the fact that I'm doing a for comprehension, I have access to the URI itself. So this is my actual backend URI. Then I'm going to have my response as, and I'm going to act as a client now to this backend. So I'm going to say send and expect. Send and expect with this URI and the request. Now, I realize that the send and expect and add path to backend have the signatures swapped. So let me swap them back. So request and URI. And let me swap them back here. So request and URI. And add path to backend is request and URI. So that way we're nice and clean. So we have response with send and expect request URI. So this is going to give us back a string. So this is the actual response. And my result is going to be an OK with response. And I'm going to yield result. This is my actual HTTP response that I'm going to surface back to the user. So I'm shuffling the replicas, extracting the first replica in the first line. And later, I'm going to do the last two operations, forwarding the request and returning the response to the user in this for comprehension. So you can see the entire logic of a load balancer right here on the screen in just a few lines of code. So let's make sure that this works. So the load balancer exposes the HTTP routes, but I need the load balancer application to also work. So I'm going to call this object, let's call this front end or server. Front end meaning that this is the primary backend that the users are going to hit. And this object server, let's extend IO app simple. I don't really need any sort of command line arguments. So I'm going to say my override def run. This is an IO unit. Okay. Now, in this case, I'm going to have a server resource, and I'm going to run a for comprehension. And in the for comprehension, first of all, I need some seed nodes. So seed nodes, and in seed nodes, I'm going to have a resource .pure, and I'm going to have a seed nodes as a URLs data type, and this is an opaque type, which means that we're going to have a little extension here. So extension, and I'm going to have some URLs as a vector URL, and I'm going to convert that, so def to URLs, as URLs applied to URLs, and I'm going to have a companion object of URLs. Just to expose the primary API, so I'm going to have a def apply with URLs as a vector of URL, and this is going to return an instance of URLs as the actual thing that I pass as arguments. So no conversion actually needed. Okay. So I'm going to say resource pure. I'm going to say vector with a bunch of nodes like localhost 8081 and with HTTP in front of it. So localhost 8081 and then 8082 and maybe 8083. I'm going to show you how you can pass these as configuration if you want to make it extensible. So seed nodes is resource pure vector and so on and so forth .to URLs. Okay. Now apparently my IDE has fired up. So let me go save. And I probably have some compiling errors. I'm pretty sure of that. So let me go to the top. We have a URI here, not URL, URI, not URL. And we have resource. I need to import that from cat's effect. So resource pure. And vector to URL is not a member of vector string. You know what? Let me actually cut this out. So I'm going to say resource eval instead, and I'm going to define a little method here. So I'm going to say def seed nodes or get seed nodes. And I'm going to force this to be an IO of type URLs. So I'm going to hit this question marks, resource eval get seed nodes. I'm going to yield unit for now, and I'm going to have IO unit just to make the code compile. All right, so the code seems to have compiled successfully. Okay, so get seed nodes. I'm going to do this later, so I'm going to show you how you can actually read this from config, which is a little bit more powerful. Let's do the backends as the ref of IO URLs. So I need to build the ref. So I'm going to say resource eval, and then I'm going to build ref of, and I'm going to use the type IO and URLs. And I'm going to have my seed nodes inside. So this is my actual atomic reference. Then I'm going to use that as an argument to the load balancer. But first, I need an HTTP client so that I can create this little function to send and expect. So let me go create the client now. So I'm going to say client as Ember client builder, default of type IO, and then build. Now on this client, I'm going to create my little function. So I'm going to define it above. So let's call this send rec on a client. So client as client of type IO. And this is going to be a function. So remember in the load balancer, I need to provide a function request URI arrow IO string. So given my, so was that request and IO and URI gives me back an IO string. Okay, so let me put this as request of type request IO and URI. I am going to say client expect, and I'm going to expect a string. And I'm going to have my request with URI. So the URI that I've computed prior, I'm going to put that in the field for the request. So send rec. Now, this send rec function applied to client is going to be my second argument for the load balancer. Okay. Now, the next thing is the load balancer. And I'm going to use load balancer dot, and I think the method is called build. I'm actually going to call this apply, really. So load balancer. And I'm going to call this method apply. So I'm going to say load balancer with the following arguments. First of all, we need the backends. So we have backends as the first argument. Then we have the second function. It's the send and expect. I'm actually going to copy all of these that I can reference them a little bit more easily so that I don't remember them off the top of my head. So with the backends, I've supplied that. Send and expect is the function send rec on the client that I've just built. Then we need a function to add path to backend. So I'm going to supply that. So I'm going to have a def, let's call this add request path to backend. And I'm going to have my request as request IO and a URI. So URI as URI. And I'm going to keep this unimplemented for now. So this is my third argument. So add rec path to backend. This is lifted to a function. Then the update function URLs to URLs. This is where my round robin logic or shuffling can be put in the URL's opaque type itself. So I'm going to have a val, let's call this round robin. Round robin is a function URLs to URLs. And I'm going to say vector. If vector is empty, I'm going to return the same vector. Else, I'm going to return vector tail and then vector head. So the head is being placed at the end. And vector mutations are very, very efficient, which will make this function very fast. So I'm going to use the round robin function as an argument to my fourth argument here. So it's going to be URLs.roundRobin. And then the extractor is going to be URLs to option URI. I'm still going to create a little function here. Let's call this val first as URLs to option URI. And that is going to be this dot head option or v or vector arrow head option. Okay. So this is going to be underscore head option. And this first thing I'm going to pass as my fifth argument. So URLs dot first. And these are my arguments to the load balancer. So this is going to be an HTTP application. Okay, let me save this. Hopefully I don't get any compiling errors, but apparently I do because the load balancer apply doesn't give me any resource. So let me actually return, let's call this routes as HTTP routes, and I'm going to return a resource. So I'm going to have resource pure routes or not found. In this case, the apply method is going to return a resource of type IO and HTTP routes IO. So I'm going to go save this, not resources, but resource of type IO and HTTP routes IO. In this case, the or not found changes the type signature. So I'm going to say resource pure routes, and that's it. I'm going to use the or not found when we start the actual server. So after we create the load balancer, which is an actual resource, now I'm going to start my server. So server, I'm going to say Ember server builder, and I'm going to have my default IO with host, and I'm going to use some interpolators from the package Comcast Ip4s, and I'm going to import everything. It contains some interpolators as well. So I'm going to say host localhost, and with port quote 8080, let's say. And then I'm going to say with HTTP app, and I'm going to use my load balancer or not found. This is the place where I'm going to use not found. And then I'm going to say build. Okay, and in this case, I'm going to yield my server. So this construct allocates the resource necessary for the load balancer to work. And now with my server resource, I'm going to call use. And considering the server inside, I'm going to say IO print line, rock the JVM load balancer. And I'm going to use an IO never so that the application never stops. And that's essentially it. So this is my server here. Let me actually call this big app. And before we start the application, the big app, I will want to implement the debt that we need to pay, which is the add request path to backend. This is a simple function. The get seed nodes is going to be a little more complex, but not that rocket science. So add request path to backend is going to take a request IO and URI, and this is supposed to return an IO of type URI. This is super important. So I'm going to return an IO pure because the expression here isn't really all that big of a deal. So IO pure, and I'm going to have my backend URL, which is this URI that I've passed as argument. And then I'm going to say slash, so all the path parameters extracted from the request. So I'm going to say request path, request URI path, and I'm going to say render string. So this is going to be my slash user slash whatever. And I'm going to say drop while, and I'm going to say underscore not equal slash. So maybe we'll have some tokens before the slash. I will just be interested in the slash user slash rock the JVM, maybe with extra query parameters like ID equals 123 or whatever. So this is the actual string that I'm interested in, and I want to attach it to the original URI of the server. This is why I've done this. Okay, so this is the add request path to backend. The get seed nodes is going to be a little bit more interesting because I will want to parse the seed nodes from the application.conf. So application.conf, if you take a look at this little configuration, is the configuration for the application described by the blog post. So the configuration is a little bit more complex than that, but the backends here is the item that we need. So I'm going to use the config reader from type level. So I'm going to say config source, and I'm going to say default at, and the namespace is called backends. So this is the field in application conf. And then I'm going to say load as a list string. And the config reader library knows how to read strings, but I need to parse them as actual URLs. So I'm going to say map. And these strings, we're going to actually parse them into URIs. So I'm going to say strings map, and I'm going to say URI from, I think it's called unsafe from string. Unsafe from string. So right now we're going to have an IO of list of URIs. So I need to turn that into a vector. So I'm going to say map underscore to vector, and then another map underscore to URLs. So right now I'm going to have an IO of URLs. And if parsing was unsuccessful because we're using the unsafe from string, this will give us back a failed effect. I'm going to say left map, and left map is an extension method from cat syntax. So import cats syntax all. So left map, and in case we get a failure or an exception, I'm going to say new runtime exception with can't parse, and I'm going to use failure there, or E, whatever that called. Okay, so get seed nodes is going to return me an IO URLs. Let's check compile status, and I think I have a compiling error. And one error is because I'm comparing characters to strings, and that makes all the sense in the world. So I'm going to have underscore not equal to the slash character. And this other bit is I'm doing an either here, and yes, I'm returning an either, so I need to wrap this IO from either. That's why I've used the left map. So if the either returns a left with this runtime exception, this will give us back an IO, a failed IO with a throwable. Okay, so let me go save this, and we should get into success. Okay, so at this point, we should be good to go. Let's start up our replicas. So I'm gonna use run main rock the JVM load balancer fast replica 8081. So replica port 8081, let's do the 8082 and 8083. And if we look at application.conf, this is exactly what we're doing here. If you don't have an application.conf, make sure you store it into source main resources. The file needs to be called application.conf, and you can add a single configuration here, backends equals, and then an array, and then you can pass these strings, http// localhost 8081, 82, 83. Okay. So we have our replicas up and running, replica 1, 2, 3. Let's start the big application. So I'm going to start another SBT. And this SBT is going to run my big app. And the big app will give us back the HTTP responses from the replicas. So I'm going to call run main com rock the JVM fast big app. All right, so we have Rock the JVM load balancer. Okay, so we have replicas and the load balancer in front of all of them. Okay, so this is the load balancer. And then I'm going to start another console here to do some HTTP posts. So HTTP get at localhost 8080/user/rock the JVM. And notice that we've gotten a response from replica at 8081. If I issue the same request again, notice that we get response from replica 8082, and then 83, and 81, 82, 83, and so on and so forth. So the replicas are cycled in a round-robin logic. And the URL itself is preserved. So let's call this feed, and we have interests equals, I don't know, Scala or something like that. Well, apparently I need to put this in quotes, and probably it's the same with curl as well. Scala. So notice that the path is /feed, and the query parameters are actually stored in the request. So if you want to surface those out, you can also make the replicas print that particular thing. So you've accessed with request URI path, and you can access request dots, and there are a bunch of headers, and you can also extract path parameters there. So notice that in just about 100 or so lines of code, we implemented a load balancer, the logic of which you can see here on the screen, just 10 lines of code, plus the necessary resources and replicas and whatnot to make it actually work. So there you have it, folks, a load balancer in Scala with some type-level libraries in the span of an interview system design question. I hope you liked this video. If you find it useful, go ahead and click the like button for me and subscribe to the Rock the JVM channel. Check out my videos at Rock the JVM. Check out my website at Rock the JVM. I have literally hundreds of hours of everything in the Scala world. Check out my type-level rite of passage gigantic online course. This is a project-based full-stack Scala course with the type-level libraries. I'm pretty sure you'll love it. And in the meantime, folks, I'm Daniel, signing off.